So my audio just cut off. Yeah, it was really tiny before. No. But now, look, blind homies can see this. My blind homies with the glasses, we can see now. Alright, so the intentions of this program was, if you know, I'm interested in Linux and how the operating system work. And everything in Linux is a file, but that's a digression. So I want to understand what's happening between the user level and the kernel level, and how programs can call some things, but not call other things, depending on how we use our program. I'm gonna be using C. I'm not the most knowledgeable, but the essence of this program is to 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 kind of follow the execution of your program as it goes. So, this is how someone new to programming will read a file, because that's how it is, right? You go to school, they tell you this is how it's done. Make sure you have a file that's a pointer to an open file, right? However, if you read how Linux, there's a book on Linux, right? I think it's this one. I believe, yes. Understanding the Linux kernel, you're gonna see that there is a different way. We can use C to actually call the kernel, right? Walk in the kernel space using C, right? Because everything you have in normal programming now is an abstraction away from hardware as possible. Even C is an abstraction from assembly, right? So yeah, I'm gonna be using this file right here that I'm working on. Is just a straightforward way of writing into a file. So what we're doing is we're going to read from a file, get all the things I read from that file, and store it in a buffer. And then we write whatever is in that buffer into a different file, because that's how we want to do it. And by writing, I just mean, hey, we want to append it to the end of the file. So what do? I open the file and I say this is just going to be a mode of type read. We're only going to read from the file. And in this file, F1 is just hi, and then F2 is welcome. So excuse me, we're going to read from file 1, which is just a hi, and append it into file 2, or file 2, whatever you want to call it, F1. Whatever we read from F, which is we read hi from F, and then we append that hi into F1, right? And F1 is welcome, right? So yeah, that's all we intend to do. And I'm not even checking for if the file doesn't exist, because I know it exists, so I don't want to do any error checks here and there, right? But as you know, you gotta check OBS, man, see if it's working. I haven't configured everything correctly, but yeah, sure. So I'm gonna move on. I'm torn here, right? Because so you want to read. So while, I think you want to do a while here, and you want to do byte. I want to do a bytes read. It's gonna be equal to f read, right? I don't know if it's f read. Is it f read? F read is gonna take a void pointer, unsigned long, and then a file. Is that what I want to do? Is it f get? Is it this? Something has to be able to give me a read. I know this. Well, we can print it to see. So let's print whatever is in here in the buffer. Right, print this buffer, right? Like that. And let's go from here first. Right, this should not be a problem. Cool. All right. Let's do gcc o file.o, right? And then let's do file. Okay, so hi is printed. We have hi, right? That's fine. That's all right. Okay. All right. So now I know that we've written it, but what I want here in this file, as I open it, I want to get, I don't know, is it put, f put c, is it f puts? I don't know what a restrict is. I guess you want to put whatever is in, yeah, I think it's f puts. But then, you know, the problem is if you do f puts and you put buffer into your right, that will override, correct? You know what I mean? That will override. I'm not sure. This may override data, and that's not what I need. That's not what I need at all. But what can you do? You have to run it. All right, let's run it, and let's run it, correct? All right, let's cat, what is in F1? See? Now we've overwritten our data. Not what we want. We don't want that. Definitely not what we want at all. Yeah, see that? I don't want that at all. So, welcome it is. And now, here, we don't want to just put. We want to put, let's see, I know we have to while somehow. F gets file C, F gets, what do you return? I want to know what you return, not only F gets. Let's see. Interesting. So, what is my dilemma? This is not what I want. It is what I want, but not really. I need like an offset, right? I need to read to the end of the file, which means that in this file, I want to read to the end of the file and append. I can cheat, right? I can cheat and just do append, right? Append, and this I believe should work, correct? So if I do this, I do this, and we cat, we can actually bat this F1. See, we have that. That is good. All right, so let's go with that. Let's go with that. Let's say now we are done. Let's see where this takes us to. All right, so let's return this back to normal, right? This is back to normal. Now let's do reader. Now in reader, we are going to use something called a file descriptor. A file descriptor is basically an object that tells us a lot of things about our file that's open. So first, and this is using the Linux way, right? You're actually interacting with the kernel space at this point, I believe, right? All right, so I'll do int fd for read is gonna just open, correct? So open. What file are we opening? We're opening f1. The O flag, this flag is gonna be just O read only, correct? Do we need anything else? Do we need anything else? I doubt it. Right, cool. And we will do the same thing here, right? So find R and change it to W. And here we're going to O right. I think it's O right. Read right. I don't know. And O right only. I guess you can use append as well. O append. Cool. So the same thing, nothing different. And we're going to return 0. And guess what? We're going to always close. But now it's going to be a different close, right? It's going to take the F, R, and write that. Find R, change it. We're done, right? Implicit declaration of what? What exactly? Is it a file descriptor? Is it this? No, exactly. What are you complaining about? Okay, so it doesn't know where close is. Probably standard out, you know. stdio. How about that? Not in IO. How about stdlib? Not there either. That is terrible. All right, go upstream. Man, close. The uni std, and now we're good. Now we are good. All right, cool. So what do we do here? Here, I've read. I want to read, and I guess we can put it in a buffer here as well. Def, I'm gonna have a size. That size, as we know, is gonna be just, let's put 3. Oh man, I'm still in cap lock. Well, whatever. Def, define a macro. I'm gonna call it size. It's gonna be 3. Cool. All right, good. So we have this macro, and I want to read. Right. I'm gonna want to read buffer size and size of the buffer. Right, so let's create a buffer. I think it's a char buff, and it's gonna be a size, correct? And it's gonna take a file descriptor, right? It's gonna take a buffer, and this is our buff. It's gonna take the size, take size off our buffer. I think that should do it. don't know what this is gonna do. So on read, boom, takes the size and return a t, whatever that t is, right? So that buffer, whatever that t is. So let's create a char. I guess that was bytes red, not bytes red, but you know, sst that, and that'll be bytes red. Yes, something like that. Let's set variable bytes red, set but not used. Okay, so we set it. What is this now? Let's print f debug, right? What is bytes red percent s I don't know what bytes red is. That even the value to use? Char, but so what is that? Format specified type char, aka long. What is this? I don't know what this is. So do what? Copy. Now we're going to go here. Whoa, what is that? Google. What is this? So this just tells us the size of what's been taken, correct? Oh, this just reads the size of what's been taken. So we read it into here. You know what we want? What I want is actually whatever is in my buffer now. What is in buffer, correct? Let's do that. I want to know what's in my buffer. All right. And what am I gonna run? I'm gonna run gcc and now we are in reader, right? So I'm gonna give it reader dot.c. Huh? What? What's that? Bytes red. Huh. Wait, what? Why did we do that? Why did I do that? Oh, you scummy idiot. Now we have hi is in the buffer. Correct. That's what we need. So I'm gonna seek into it. Right? So now, time to append. Let's try doing this. All right, let's try. All right, let's go now. So we know that works. We know what's in our buffer now is the data we need. So now, time to read. Sorry. What do I need to do? I need to write. So I'm gonna write into a file descriptor, right? The buffer, buff, and our t size. because I think it might override t size. Why don't I just give it size and c? Right, like size, like that. Right, and see what happens. Yes, that's what you do when you experiment. Right, cool. All right, I think it may override, but how do you know if you don't test it? Now, I'm gonna run that. Nope, that's file. Gonna run reader hi, and I'm gonna check F1. F high. Interesting, but which high, right? Because I run something else first, so that may have corrupted whatever we have, right? All right, so let's clean high, right? Now we know it's this, and I'm gonna run reader cat. It didn't even write. Then write to the file. See, I must have gone on. I would have. So you always check. So we write to this a buffer type size, maybe size of buffer. Correct. So we write here. Let's write read to the buffer, and then we write into here. This. Isn't that it? What am I missing? Reader cat. Not right. F1. Still not doing anything. Well, I think I know why. I think. I think it's because I have to do gcco reader dot c. Let's do reader again. Cat F1. Oh, so even with that, nothing changed. All right, cool. So something is wrong somewhere. So we want to write into the file, right? Okay. So this read write and cat. Still the same thing. So I read into here. All right, so let's read on write. So writes up to count bytes from the buffer starting at buff to the file referenced. So write to a file descriptor, give it the file descriptor, give it the buffer, write up to count bytes. So count by, so that's 3 bytes from the buffer starting at buff to the file. So it's supposed to write to this. So we open it. Oh man, what am I doing? What the hell was I doing? Okay. So that's not good. Let's do this to make sure that we're not doing the same thing. So for file.c, are we doing the right thing? Correct, we are. So now I want a cat. Oh, it was writing. All right, it was writing. All right. Okay, so this is not what I want. What I'm going to do is I'm going to go back to our program and I'm going to correct the sins of its father. Good. All right. Okay, so now we'll go back, reader, and that, and then now we will cat to C. And it did what I didn't want it to do. Right? Hi come. That is not what I wanted to do. I wanted to append. All right. So let's see. Reader. How about say append? Let's see what append does. Right? Cool. File. Icon is not what I want. Right? Reader. Right. Or let's say append. That's what I want. Just apples to apples, correct? All right. Let's do an apple to apple cat f1. Did not write to it. Read. Let's try doing this. Read and append. This is proven more difficult than I want it to be. Alright, so it's not working. So let's do find a right. But you know one thing, right is gonna take this, so why don't we do this? Let's do an offset. So L seek. So seek is gonna seek the F, right? We're gonna give it an offset of let's say 0. I want to give it an offset of 0. Maybe. Lens is goodness gracious. Lens is gonna be seek end. How about that? Right. Seek the end. Seek end. It's gonna give us that of this one, and then we're gonna use it to write. Correct. Let's try this approach. Good. So it did. It wrote. Now, right? Now I'm going to run file. Let's run f file. And then we're going to cat this. So now as you can see we have two, because the first running was read, right? So we run the reader, which is using just kernel, read and write, and open, whatever. And so it appended to this file, welcome hi, and then we called the normal file one, which printed high, and then it appended the last high at the end, right? So now let's go up. Let's do this. See? All the same. All right, cool. Now, what I want to do, right? What I want to do with that file is to take it out, and for each successful reading, right, for each successful execution, I'm gonna add like a tracer. It's actually called trace, right? I'm gonna say, okay, follow this, and put for the first one, which is just file, just append the output into a file I call X. And then for the reader, we're going to have another file for that reader, and we're going to call it x.txt. Now, what I am going to do is I'm going to move back. So we have this, whatever this is, right? Because this just takes and append the second one, correct? Reader. Right, cool. Reader did that. All right, what makes sense. Okay, so I am going to do an F that, right? And here I'm going to take X, and if I control, I am going to take this one, reader and writer, correct? And I am going to close this, and I'm going to reduce. I'm going to definitely reduce that. Close. All right, VS, and that's reader. Let's see what this is. Reader, and this is file. All right, so this is from our execution of just a regular file, and you can see by the content, the count we have. When you call the system itself, it makes less calls to the kernel because you're just talking directly to it, albeit it's not as much, but you're still doing less work. Simple and short. Like, you can see, right, that in file we're still doing a seek and we're giving it 5, but here we've already done it, right? In the reader we've already done it. We did it ourselves. Better. That's all I have to say. And with that, I hope you are convinced that this book has taught me something about my system and how we do reads and writes. Thank you, and I'll see you another time. Talk to you another time. All right. Where's OBS?